Hello everyone, my name is Yifan Ding. I'm from University of Central Florida. Today I'm gonna present our work analyzing deep neural networks transferability via feature distance. This work was done in collaboration with Dr. Liqiang Wang and Dr. Boqing Gong. In deep learning, the size of the training dataset has played a very important role to the success of computer vision tasks. However, it is very expensive and time-consuming to collect and label those training data. That's also why people tend to use techniques such as transfer learning to transfer the knowledge we already learned from some bigger datasets, such as ImageNet, to some smaller dataset, such as the Caltech UCSD BERT dataset. And if we look into those pre-trained models we can easily find online, it is often the case that only checkpoints with the best performance on original tasks are provided. That makes us think that a better pre-trained model always generates a better transferred model. We have doubt about it. We then conduct experiments to verify it, and the answer is no. In our experiments, checkpoints are saved every a few iterations in the pre-training stage, and then we conduct transfer experiments with those saved checkpoints as the initializations. During the transfer learning stage, the best validation performance achieved are recorded and plotted as the blue lines in the figure. The yellow lines denote the pre-training performance. Those experiments are conducted among 3 networks and 2 dataset pairs. It shows that pre-trained checkpoint with better performance on source tasks does not always lead to better performance on the transferred models. Specifically, for AlexNet and the ResNet 18, when the pre-trained performance is still increasing in the last few epochs, the transfer performance starts decreasing. This symbolizes the transferability decreasing of the pre-trained models. In order to find the best pre-trained checkpoint for a target task before conducting the transfer experiment, we propose to use feature distance to measure the transferability of a pre-trained checkpoint while we feed the image features into Gaussians. Specifically, for a given pre-trained network f theta, we first gather the features on the source dataset xs and the target dataset xt. Then 2 Gaussians are fitted on the source and target features respectively. Finally, the feature distance is computed among the 2 domains, which we call it as featured pre-trained distance. And here are the results, in which the blue lines denote the transfer performance and the yellow lines denote the value of featured pre-trained distance. The x-axis is the number of iterations. We can see clearly that the value of transfer performance and FPD is well negatively correlated, which indicates we could use the value of FPD to find the best pre-trained checkpoint. From the previous experiment, we found that for AlexNet, the transfer performance of a model initialized from a pre-trained checkpoint can sometimes be worse than trained from scratch. To avoid this to happen, we apply spectral normalization to the pre-trained model. Then the transfer performance can be recovered. We also investigate the per-layer FPD, and it shows that over-parameterization may hurt model's transferability. Furthermore, we also conduct more experiments on different learning rates, as well as different ResNets, and the results consistently support our conclusions. To conclude, we investigate an easily overlooked phenomenon that a better performance on the pre-trained checkpoint would not necessarily generate a better transfer performance. We also propose to use featured pre-trained distance to indicate a pre-trained checkpoint with better transferability. Finally, our current work is mainly experiment-based, and we are working on more theoretical studies. For more information, please check our full paper, and for any questions, please contact me through email. Thank you.